Hey, geometry students, welcome to lesson 13 and buckle up. It's going to be a long one. We are going to be introducing triangles in this lesson, and anytime we introduce a new shape, there's going to be a lot of definitions that you have to keep track of. So I'm encouraging you to take notes, make sure you're working really hard to keep everything straight. There's going to be 3 videos for this lesson, so make sure that you're taking the time after each video to sort of mentally review what you've learned in the previous video. And let's get started. The first thing we're going to do is define geometrically what a triangle is. Definition of a triangle is it's a 3-sided polygon. Now this definition may not be so useful if you don't know what a polygon is. We haven't talked about polygons yet. A polygon is just a closed shape in a plane, so it's flat, okay? The fact that it's closed means that all of the sides come together at vertices. We'll talk about what a vertex is in just a second, but all of the sides come together. There's no openings in the shape. And it's bounded by at least 3 straight sides. Well, wait a second, a triangle has 3 straight sides, so a triangle is the smallest polygon. All right, and now that we know what a triangle is, let's talk about the parts of a triangle. The first part of a triangle you need to know is called the vertex. The vertex is one of the points where the 2 sides of the triangle intersect each other. How many vertices is a triangle going to have? By the way, vertices is the plural of vertex. How many vertices is every triangle going to have? Well, every triangle is going to have 3 angles. That means there's 3 places where sides come together and intersect. So every triangle is going to have 3 separate vertices. You see that this triangle has vertices at A, B, and C. This right triangle has vertices at D, E, and F, and then this triangle looks a little odd compared to the other 2. This has vertices at H, I, and G. Okay, so all of these triangles have 3 vertices because triangles have 3 angles or 3 places where the sides come together. The base of a triangle is just one of the sides. And once you choose the base side of a triangle, you're locked into that side being your base. So it's important for you to realize when you choose the base of your triangle, you can choose another side to be the base if you want to, but the calculations that you do once you choose the base are always based on that being the base of your triangle. And then lastly, the height of your triangle. This is a lot easier to actually envision on your own. It's a lot harder to describe. So it gets a little wordy, this definition, but you'll see why in just a moment. It kind of has to be. So the height of a triangle is the segment that's perpendicular to the line containing the base. So the base here, remember, the base is just one of your sides. You extend the base in either direction with a line. The height is perpendicular to that line. And then one endpoint of that segment is on the baseline. The other endpoint is on the opposite vertex that's opposite the base side. Now it's important to realize that that height has to be perpendicular to the baseline. That really locks it into just being one particular line segment in your triangle. Now you'll see down below, I have 3 triangles here. The left one is a typical triangle that you're kind of expecting when you think of triangles. Notice that the base is at the bottom. I've chosen this as my baseline. The height has to be perpendicular to the base, and it extends to the vertex that's opposite the base. Could I have chosen AB as my base? Well, sure. If I did that, I would draw my height perpendicular to AB and then passing up to the vertex C. And I could do the same thing if AC was my base. Next, I have a right triangle. Notice that if I set up my right triangle the way you're used to setting up right triangles, with the hypotenuse diagonal and the other 2 sides horizontal and vertical, the base can be the bottom side, and then the height is the other perpendicular side. Okay, the other leg. The hypotenuse then is on the top. Could I make the hypotenuse the base? I sure can, and then my height would be the line that's perpendicular to the hypotenuse that reaches side, that passes through with an endpoint at point F. Right, and then my last triangle is the one, that reason why it's hard to define what the height is. The reason why my height definition is so wordy. Because notice that in this triangle, the height is perpendicular to the base line, but it doesn't actually touch the base. The height falls outside the triangle. That'll happen when you have these obtuse triangles. We'll talk about what an obtuse triangle is in the next video. But if you choose one of the sides of your obtuse triangle to be your base, that's not the longest side, you may have a height that falls outside of the triangle. The key is that the height is perpendicular to the line containing the base and then passes through the opposite vertex. The vertex opposite the base here is H. Now, this could all be fixed. Instead of choosing GI to be the base, if I chose HG to be the base, then my height would fall inside my triangle and would be a little easier to deal with. All right, in the next video, we're going to talk about the types of triangles as well as how to calculate the area of a triangle.